Class, good morning to you. Today's topic is real world applications of linear equation. And if you remember, where last time we have ran linear equation. You remember? Linear equation, well, if I remind you, it is a equation of a straight line. And the equation, you remember that it is a statement that the value of two expressions are equal. And that straight line, if you remember well, it can be vertical, it can be horizontal, or oblique. An oblique line is neither vertical or horizontal. So today we are going to see how one of the forms of linear equation, which seems to be like this, where we have y, which is equal to mx plus b, and the y here is what we are looking for, or what we are trying to find, and we take it as dependent variable. Yeah. So y equals to mx plus b. This m stands for what? This m stands for what? It is a slope, and it is how much we change. How much we change. X, and this x that you are seeing here, it is independent variable. What you choose. I can choose any variable or any value that is different from what you can choose, right? So and this b, it is y-intercept or constant. You can't change. It cannot be changed, right? It is a constant. Then as you see this question, as you see this equation of linear, today we are going to see some applications where you can apply linear equation. There are so many different areas that you can find, or you can find somewhere to use linear equation, like in construction, masonry. You're gonna see one of the application. In economy, as you can find profit by using SP, this is selling price minus buying price. You can use linear equation in buy a thing. You can use linear equation in computer graphic or animation, in 3D or 3D or 2D. All of there it is possible. And there are some there is a procedure that you can follow so that you can solve word or real life problems. Okay, so you can use this procedure. First, you have to read the question or the problem carefully. Secondly, you have to assign the variable to represent the unknown, right? That's the second. The third, you have to form the equation by using that letter or that variable. So the fourth, you have to solve the equation. Then you have to state the answer in terms of that problem. You have to state at the end. You have to say what you asked. You have to express this in a word. Then finally, you have to check the result, right? Another thing that I have to remind you is that whenever you are going to solve word applications in linear equation, there are some keywords that you have to understand. That's in English. In English, shared, and then you translate them in expressions algebraically. So those keywords are like when you have plus, add, total, more, together, increased by, sum. All of those are common addition phrase. Those are phrases, English phrases, that you can translate in algebraic expressions as the addition, right? Another thing is that whenever you find the minus, difference, subtract from, less than, less, or decreased by, diminished. Those are phrases, those are common phrases, the same as what? Subtraction, subtract, right? Another phrase that seems to be like a multiplication is when you are asked to multiply product times half of, twice, triple, triple 3 times, twice 2 times, something like that. What seems to be like you have to multiply, right? Another common phrase is as addition is like quotient or divide or ratio, pair. Those are phrases that are common to division. So whenever we find these keywords, you will use algebraic expressions that are different. Now let's start from one examples of linear equation. Here I have around 4 examples, and at the end I'm gonna give you 10 exercises. That seems to be like the one that you are doing. The first example says that Mr. Theogene Papaganza created a YouTube channel and started with 10 subscribers. 10 subscribers, maybe there are 10 students. He plans to find 5 new subscribers each day. Number 1, create an equation that describes how many subscribers he has each day. That's the first equation. You have to create what? Equation that subscribers, how many, that will describe how many subscribers. Secondly, how many subscribers will he have after 20 days? This is the first example that we're gonna see together how you can solve such equation like that, this one. Then, first of all, you have to understand this one. You have to understand what we call started with. Started with. This started with stands for what? It is a constant because it is like amount started for.
You have to turn on Wi-Fi.
You have we have started for with 10. If it is whenever you start, we find started with means the constant. It's gonna be the b, the value of b. It is a constant. Then he plans to find 5 new subscribers. It seems to be like the value of x will change with 5. And what we are looking for, subscribers. If you are looking for subscribers, the subscribers x will stand with these subscribers. X, let x be the number, this stands for number of days, right? Number of days. And y will be the number of subscribers, right? Then we are going to create an equation because we are looking for subscribers, right? It is y equals to what? 5 gonna be the slope, like it's change, the value of x will change with 5, right? So it will be 5x plus c started with is a constant. It is 10, right? So this is the equation that we was looking for, because here we were asked to create an equation that describes how many subscribers he has each day, right? Now, second number, it says how many subscribers will he have after 20 days. What is 20 days? 20 days, it is x. It means x here equals to 20, right? Then, when you substitute the value of x by 20, y will be equal to what? It is 5 times 20, then plus 10. Remember, we started from multiplication. We have to multiply 5 by 20. Then the answer is what, class? The answer is 100, isn't it? Then plus 10. 100 plus 10 gives us 110. This is the value of y, right? The same as here. Then, this is the first step, and we are about to we have to translate this in terms of word problems. We are asked to find how many subscribers will he have after 20 days. Start from after 20 days. After 20 days, Mr. Theogene will have how many subscribers? 110 subscribers, right? All right. Okay, let's together see how we can solve the second example. So, second example says that concrete, concrete is a mixture of cement, sand, and aggregate. And then, if 4 kilograms of sand and 6 kilograms of aggregate are used with each kilograms of cement, how many kilograms of each required to make 1,200 kilograms? I understand this question? Okay, let us try it together. Now, let us suppose that, or let X be amount of cement, because it is 1 kilogram of cement, right? It is, if within 1 kilograms of cement, we use 4 kilograms of sand. So we shall take 4x as the amount of sand, right? Now, within 1 kilogram, we use 4 kilograms of sand. We also use 6 kilograms of aggregate. X is amount of cement, 1 kilogram, 6 kilograms. It means 6 times x be what? Be amount of aggregate, right? Now, we want to make a concrete of how many kilograms? Of 1,200 kilograms. It means 1,200 kilograms is total amount. Total amount means x. We don't know the amount of cement, it is x, plus the amount of sand for x, plus 6x equals to what? Equals to 1,200, right? Now, x plus 4x plus 6x gives us how many x's? Here it is 11x equals to 1,200. Now, how can you find x? We divide by 11 here and divide by here. So it's gonna be, let us divide 11 here. 11. Divide also 11 there. Then 11 divided by 11 is x. The value of x here equals to what? 100 to 1,200 divided by 11. Maybe this number cannot be divided by 11. So, can we change it a little bit? Let us change into the equation. Put 1,210. 1,210 kilogram. Okay, so that this number can be divided by 11. So whenever you change here by 1 and there by 1, so it will be divided by, the number can be divided by 11. So how much is this? It is 110, isn't it? So it means the value of x here, it is 110. And remember, x is amount of cement. So now thus 110 kilograms required. Kilograms of, yes, of, this is of what? Cement required to make what? That concrete. So how about amount of sands? It is 4 times x, which is equal to how much? 4 times 110, which gives us 440 kilograms of sand. Okay, so and then we also want to look for amount of aggregate. How many kilograms? It is 6x, 6 times x, which is equal to 6 times 110, and this gives us 660 kilogram of what? Aggregate required. Let us add required, right? So this is the way you can solve such equation like this one as well, which is here we have applications of linear equation, because 11x equals to this one. We solve this as a linear equation, isn't it? So the third example says that given a supply of equation, so we have a supply of equation which is QS, quantity supply equals to -24 plus 3p, and demand function is this one. Quantity demand equals to 80 minus 5p. For any commodity, find the price and the quantity of that commodity at equilibrium. You know, if you remember, where at equilibrium, market equilibrium, the quantity of the amount of product produced should be equal to the amount of quantity demanded, right? Now, if you remember, where as we have graph that seems to be like this, right? Graph for demand and supply. So this is axis for quantity, and this is axis for price, right? Do you remember? Price. So we can choose P as Q and P as a point that you can find equilibrium P and Q, and they made somewhere here, and this point is a point of equilibrium, right? This is a point here, it is at equilibrium, and this demand, and you can take another line to be a line for supply. Right. This is a quantity at equilibrium, and this is price at equilibrium. This is what we are looking for. At equilibrium, quantity demand at equilibrium, quantity supply equals to quantity demand. It means this negative 24 plus 3p equals to what? Equals to 80 minus 5p, right? Let us take this to the right hand side. It will be 3p plus what? 5p equals to 80. Let us take also 24 to the right hand side. So it's going to be positive. Positive what? 24. So now, how many p? It is 8p, which gives us 104, isn't it? How can you find p? P, we divide a here and a here. So p equals to how much? Let us put 1, it is 13. The value of p here, it is 13. Remember, p is what? P is price. Price at equilibrium. And this is what we are asked to find the price. So asked to find the price, this is the price. So let us find the quantity. How can you find quantity? You can substitute in any equation like among these two, quantity supply or quantity demand. So let us substitute in quantity demand. Quantity demand equals to what? It is equal to 80 minus 5p. So the value of p, we know the value of p. We shall take 80, then minus 5 times 13. And this is 80 minus. This is 65. And then 80 minus 65, it is 15. This is the quantity demand. And we shall take this. Is what is the quantity at equilibrium. All right. So this is what we was asked. Quantity of that commodity, it is 15, and the quantity, the price is 13. You can even put here 13, and there price to be 15, isn't it? So this point is at the equilibrium of quantity and the price. So we can use linear equation in even current depreciation. As long as you continue studying linear equation, I will also show you the equation where you can use linear equation as a current depreciation. As long as the industries continue producing new cars, new brand cars. Yesterday we had the Mercedes-Benz. Today you have Hyundai. Tomorrow you shall have Ford. And as long as industries are producing new brand car, we shall also see next time how you can use equation in the depreciations of vehicles. Thank you for your attention. And you're gonna try these exercise. They are around 10 exercises. You want to try them as the way we do this. You want to do the same as those exercises. Try them as exercise. We shall correct them next time. Thank you for your attention.